My name is DAMIAN HARASYMCZUK. That is my last name, but it's quite hard to pronounce, so just don't bother. I'm a software engineer at Contecht. My current work mostly focus on GIS systems and BIM systems. And I use mostly JavaScript, Golang, and Python language. So these systems are mostly web apps. So you don't need to install anything. You need only a web browser, and you're ready to go. You can play with everything. Today, I'd like to introduce to you Go Safe Rail project. It's a Horizon 2020 project. We are responsible at Contecht for Go Safe visualization platform. It's one part, so at first, few words about the whole Go Safe project. This is some academic rigmarole from our proposal, but basically it's all about railway infrastructure management, assets management, some decision-making process and things like that. Here are a few things that are integrated, few bullets, for example, integration of open data, big data sources. It's a quite big challenge because there are a lot of different sources, a lot of different formats. Real-time methods, some real-time simulations, because we use libraries like Cesium, and a lot of simulation in real time can be performed there. Of course, some AI algorithms, some machine learning, data mining, prediction, clusterization, regression, everything that can be implemented there. And it can be used to plan maintenance and intervention strategies for railways. It's not really a system for regular users. It's mostly for specialists like engineers, railway engineers, managers. There are some useful websites if someone is interested. You can just Google Go Safe Rail, and there are more information about the whole project. But I'd like to focus on our part of work. It's a Go Safe Rail platform. So basically, I think it's the most interesting part of this project, because all visualization, everything is integrated inside. So two objectives here. To develop a decision support tool, of course, and to provide GIS-based visualization models and other visualization models for micro simulation outcomes and machine learning efforts. This is a very, very basic and simplified overview of our platform. So it's this is the classic architecture. The front end is connected to the back end, and user can interact with the front end. There is a HTTPS, so it means that user can use only a browser. And of course, front end is communicating with the back end. There is also a converter which performs some more complicated task, and everything is connected to the graph database, which is something different than we know about from classic databases, right? Relational databases, or even non-relational, but something like MongoDB. So, challenge. This list is actually endless, but I choose 4 of them, like data sources integration. There are a lot of data sources used in railway agencies, in industry companies. So we need somehow to allow to load pretty much everything they want to use, like popular spatial data formats, like Exchange formats. We will talk about this a little bit later. Create a suitable data management standard due to the first point, of course, because when we use a lot of data sources, we need to somehow store them, and we need to create a unified model to visualize them on our globe here. So the data visualization mostly Cesium JS. It takes the page from the Google Earth application. It's a globe, 3D globe. So there we can display a lot of spatial data. And also we use some libraries to visualize graph charts and things like that. And the last challenge here is to integrate other GoSafe modules and service. I mean, modules developed by our partners, some external services, so like machine learning, like stuff, like real-time stuff. So this is our stack. We choose, I believe, the most popular, the most reliable technologies to do this. It's a Node.js plus React for the front end, and with React we integrated Cesium and D3. And there are two probably the most popular and the most flexible libraries to visualize data, both type spatial and non-spatial data. There is Neo4j database management systems. It's a graph database. Scikit-learn, it's a well-known library for machine learning. And Golang, of course, is used there because we have a lot of hard tasks, and it's the best choice in my opinion. Few words about data sources. So these are basic data sources. The RailML is some kind of XML exchange format. And everything that you can imagine that exists in the railway industry with every asset, that is related to tracks exists there, is described. There are a few sub-schemas. And another one is a CTGML. CTGML describes pretty much everything that exists around buildings, cities, landscapes. There are water areas, vegetation areas. IFC Rail, it's a part of IFC project. Currently, actually, it's suspended, but it's basically BIM for railway infrastructure. And few others, spatial formats like shapefiles, GeoJSON, TopoJSON, everything, just normal GML, everything that can contain some spatial data. What they all have in common? Well, they are really hard to work with them. Mostly they are very big file, hard to read by human, and it must be somehow parsed and processed before we can do anything with them. And there is our data model. There are two parts. There is a railway network, and there are objects not directly related to the railway network. We called it neighborhood. So railway network is a topological system. There are topological connections between all, let's say, tracks. It's easy to imagine how railway tracks are connected, where is the beginning, the end, and how they are related to each one. There are also some other assets like switches, crossings, and things like that. And this one is only, there is a geometry encoded inside this topological model, but without any structure like we can see here in neighborhood. There is R3 structure which allows to perform much faster queries and just grab this neighborhood much faster and stream it to the platform. So this is a GIS view. It's a Cesium viewer. Here we can see 3D buildings extracted from CTGML format and streamed to directly to the platform as Cesium tiles. There are also some tracks extracted from the RailML alongside two switches. This red dot is a switch, I believe. Yeah, this viewer works basically like other GIS software, like for example Quantum GIS or ArcGIS, if someone knows about that. And this is another visualization. This is the graph structure. This is the topological model. Probably for railway professionals, it's even much more important because they can work directly with the whole infrastructure. They can edit, they can add new tracks, assets, and everything. And some microservices are integrated there as well. This one is a real-time API. This is a real-time API provided by Irish Railways, I believe. And here we can stream real-time trains, positions. We can see some markers. Each marker indicates the current position of the train on the globe. There are also some codes, messages, so it's very useful when you plan something. There are even the expected departures, lates, how much time left. Another microservice that is integrated here is machine learning microservice. It's quite flexible, as you can see, because we store some models, some data sets and some models in the database, and we allow to choose, for example, this is the classification task, so user can choose the model, right? There is naive Bayes, there is MLP SVM AdaBoost classificator, there are some performance measures like accuracy F1 scores, or you can choose the most suitable one and you can add your values and predict. For example, this is a prediction of renovation costs, right? And with these values, prediction is over budget, so we shouldn't build this bridge or something like that. And of course, we can visualize these efforts. This is the base map with tracks, and each track has different colors, so that means there is some kind of property, maybe a probability of something, and yellow means low, red means high, so it works actually exactly like a heat map or choropleth. Or there are different cartographic visualization techniques there. And simulations. Our system can interact, user can directly, through our platform, can interact with other services. For example, OpenTrack, it's some kind of fancy service for railway management and for simulations. So we can exchange data between the platform, because we can, from our database, from our model, we can export files. We can send these files to the microservice, and we can get a response. We can update our database. Yeah, and this is pretty much all that I wanted to tell about that, and soon it should be deployed, so everyone can view this platform. And of course, it's open source. This open source repository is available on our Contecht GitHub. The name is Contecht GmbH. So thank you for your attention, and